For parts 7 through 12, we want to actually prove whether or not these triangles are congruent. Now, we don't actually have to write a similarity statement or a congruence statement, anything like that, where we have like ABC is congruent to DEF. We just have to write if they are congruent, and we have 5 ways that we can do that. Either HL, where we have a hypotenuse, a leg, and a 90-degree angle. We have SSS, where we have 3 congruent sides. We have SAS, where we have 2 congruent sides and an angle touching both of those sides that happens to be congruent. We have ASA, where we have 2 congruent angles and a side touching both of the congruent angles. And we also have AAS, where again we have 2 congruent angles and a side, but the side only has to be touching one of those angles. So as we go through number 7 here, we can take a look. We've got the right angles and we've got congruent angles. There's nothing else marked. Okay, so this one doesn't have enough information, so we can't say that those 2 triangles are congruent. For number 8, we have these 2 sides, these sides, and then the angle. And the angle is touching both of the sides. So since we have those 3 pieces of information, we can say that these triangles are congruent by SAS. In number 9, we have 2 congruent sides here. We have congruent angles, and then from reflexive property, this side is congruent to itself because when we separate the triangles, they're going to be the same piece. Now here, we have an angle only touching one side and another side that's congruent. We're not allowed to have this at all, which means that these triangles are not congruent. Now in 10, we have sides, a couple other sides, and then from reflexive property, right, we have that middle piece. So we have 3 sides, which means using side, 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 or SSS, those 2 triangles are congruent. In 11, we have sides here, and they're parallel. These lines are parallel, which means we're going to have some angle pair relationship happening. So let's say I highlight this one, and I highlight this one. It makes our Z. Okay, so now since we have the Z there, we can say this angle is congruent to this angle. And then we have vertical angles, which form our bow tie. So we have an angle, and a side that's only touching one angle. So through AAS, these 2 triangles are congruent. In 12, we have this angle here is congruent to that one. We have a right angle and another right angle because they'd be a linear pair. And by reflexive property, we have congruent sides. So these 2 triangles are congruent through ASA because that congruent side is touching both of those congruent angles.